Summer break's over, school's back. Gross. I know. But not as gross as what happens when you burp in space. We'll get to that, but first, I'm Science Ben. Let's transport outside and look up. We're actually beginning at the earliest hours of tomorrow morning, where in Virginia skies can be found not one, but two naked eye visible planets residing between the horns of Taurus the Bull. Jupiter and Mars reach conjunction for a brief bit before sunrise. Familiar patterns circling Taurus include a sideways Orion the Hunter, the bright cluster of Boots the Herdsman, and the W of Cassiopeia. If we turn to face Cassiopeia, then trail our eyes down to the Running Man, then we find the source of tonight's best meteor shower, Perseus the hero. The Perseid meteor shower peaks this month, the night/morning of the 11th going into the 12th. It lasts until early September and appears highest in the sky around 5 a.m. A dark sky with light-adjusted eyes can reveal more than a meteor a minute. Jupiter's not done showing off for the month. The morning of the 27th, the gas giant again joins Mars, but also adds a waning crescent moon and bright star Elnath to form a crossed asterism in the sky. The next morning, the 28th, Jupiter, Mars, and the Moon gather together and align. Elnath is also known as Beta Tauri. It's the second brightest star in Taurus the Bull. I never liked getting in line for the bathroom at school. In space, the bathrooms are a bit different. You've likely seen footage of astronauts moving around the International Space Station. In low gravity, we know that people and other solid objects have a way of floating around. Liquids behave even stranger. Washing your hands or hair can be tricky. One of the reasons leave-in shampoos are a popular option. When we go to the bathroom and expel urine, that urine is a liquid. Nobody wants a pee ball floating around, so astronauts combat this with suction. The space station's WHC waste and hygiene compartment features a hose for urine and a seat for solid waste that both utilize suction to not only collect the material, but to manage smells. The trap on a standard household toilet, usually in a P or S shape, collects a small amount of water to prevent sewer gas from flowing up through the seat into your bathroom. The suction on the ISS toilet seat traps the smells and material of solid waste, poop, in a canister which is routinely emptied or replaced. Liquid waste collected via hose is instead sent to the water recovery system, where a series of high temperature distillation processes is used to recycle the liquid. That's right, if you spend time on the ISS, you're gonna drink some pee.
It tastes really good.
Ah, the water cycle. What you drink while in space does matter. Avoiding carbonated beverages is a must, as you do not want to have to burp in space. Last month, CSA astronaut Chris Hadfield responded to a question on X where he explained that burps in space aren't really burps. On Earth, gravity keeps heavier digestion food particles in our stomachs, while lighter gases, released through digestion, float up and are eventually released as a burp. With less gravity in space, all the digesting material, gas, solid, and liquid stick together in a kind of bubble. Hadfield explained that burps in space are wet, adding, you throw up into your mouth. Out your mouth is one way gases can escape your body. There is, however, another route. Extravehicular activity spacesuits are sealed airtight. So if astronauts need to release a little wind during a spacewalk, are they trapped with the smelt that they've dealt? No, thanks to really advanced diapers. The MAG, Maximum Absorbency Garment, is a disposable adult-sized diaper containing sodium polyacrylate, a substance that can absorb 300 times its weight in water. If an astronaut needs to expel waste while outside the space station, the MAG can hold up to 2 liters of urine, blood, and/or feces. This helps minimize unpleasant smells released from these regions. Additionally, spacesuits utilize lithium hydroxide filters to remove exhaled carbon dioxide and expelled methane. These are all human bodily functions, as astronauts possess humanly bodies. Humans, even those off-planet, get sick. How do you remain stationary for rest when your body is sending out different forces? Like, what happens if you sneeze in space? Again, Chris Hadfield.
Okay, I'm going to turn sideways to see what happens. Here we go. Nothing. Oh, maybe I'm rotating a tiny bit. When you sneeze, of course, your body is trying to get something out of your nose, and it pushes it out pretty fast. That little bit of stuff pushing out of your nose would push you back very slightly, but you have a lot of mass, and the stuff coming out of your nose just has a tiny bit of mass, so it doesn't move you very much. But also in space, we cover our noses when we sneeze.
Well, that wasn't very extreme. If you are looking for something extreme, join us for next month's Void when we'll discover extreme weather in our solar system. Streaming live the second Tuesday of next month, September the 10th. We'll see you then. Thanks for watching and keep discovering.